Good afternoon, everyone. Man, I am so excited to be here to talk to you guys about DevOps. I live in Seattle. I never talk in Seattle. So this is like kind of cool for me, right? But before we begin, this is kind of funny. I wanted to share with y'all a real DevOps disaster story. So before my talks, one of the first things that I do is I always make sure my demo's working. I go through it and make sure it's working. So just right now, I was in the speaker room, and yeah, that's my demo. But wait, I'm sure it's just a refresh problem, right? So I refreshed it, and yeah, I'm like, okay, that's not good. And my demo is hosted all in Azure, right? All the stuff is in Azure. So I'm like, it's got to be an Azure problem. But I'll check it out, right? So I jump to my Azure subscription, and let me refresh this. There is one resource group, which is what? An Ignite resource group that Donovan is using later today, which is why I have it up and running. There should be a Mercury Health resource group. So apparently some idiot came in here and deleted the resource group that I needed for this talk. And that idiot was probably me. It was pretty late last night. I was cleaning stuff up really quickly, and I think I deleted the wrong resource group. But I should be okay. Technically, I should be okay. I use DevOps best practices, including things like infrastructure as code. So in theory, I should be able to kick off my release, and then everything just magically rebuilds itself. And by the time I'm done talking, hopefully everything will be working and just fine. So let's go ahead and kick off my release pipeline. And in the background, we can even kind of watch it live, because what could possibly go wrong, right? All right, on to the talk. So we're going to talk DevOps today, and we're going to talk real-world DevOps, right? So usually when I give DevOps talks, I have a beautiful DevOps demo. It's rainbows and unicorns, man, right? It's super cool. It's really flashy. I make a little change, and I check it in, and you can see builds run. You can see tests are running. Automated UI tests are flying everywhere, and then things just magically change in production, and voila, I'm done, right? Kind of cool. However, as we all know, the real world is a little bit different. The real world, especially for us that do DevOps, a little bit more like that, right? So what I wanted to do today was take a real world application and kind of walk through what a pipeline could look for a real world application. So what I did was, first thing I had to do was create a real world app, right? So the real world app that I did is a modern microservice-based architecture application. So it has an ASP.NET web front end, and we're talking old school ASP.NET, right? This isn't core, this is ASP.NET old school. It also has a SQL server running in the background. It also has a REST API that is written in Node that I want to run in a Kubernetes cluster. And there's also a services layer that's also written in .NET. Right? And I want to run this as a container as well. And then finally, there's a mobile app for this as well, so iOS and also Android. So using this as my application, it's a real-world app which gives me real-world problems that I immediately hit once I started to build out this demo. Right? So the first thing I realized is, even though my application is theoretically a microservice-based application, it's not ready for real microservice deployments. And what do I mean by that? The power of microservices is if you make a change to a microservice, all you have to do is deploy that one little change, right? You don't have to deploy your entire application. This way, your deployments are much smaller, much easier to test, et cetera, right? So my first thought was, awesome, I'm going to have a bunch of these little pipelines. This is going to be the coolest demo. And I tried it, and it worked 2 times. And then it failed miserably, right? Because I forgot about versioning and dependencies. They kind of matter, right? So if I have service A that depends on service B, the order that I deploy my services now really start to matter, or I'm going to get some downtime, right? And if service A depends on service B, that depends on service C, that depends on service A, uh-oh, now what do I do, right? Now, guess what? My app, I can't deploy this without some weird trickery and some downtime, which I don't want, right? So I thought about it, and I came up with a solution. I was like, okay, In order for me to truly decouple all of my services, maybe if I made my services really smart, right? If my services could talk to each other and I can say, hey, you, service B, what version are you at? You can tell me I'm on version 29. And I'll be like, I wish you were on version 30, but since you're on version 29, let me turn off my 30 feature flags. I'll turn on my 29 feature flags. Guess what? We can totally talk now. And all of a sudden, it does not matter what order my services are deployed. I can have constant uptime, right? Pretty cool. But there's one small problem. My code doesn't do that. I mean, I thought of it's not rocket science to do all of this communication, but it's not super trivial either. What am I going to do in the meantime? Because right now, my builds don't work. My releases don't work, right? So I have a solution, but it's not implemented just yet. In the meantime, what do? The sad truth is, at this moment, I have to treat my microservice-based application as a gigantic monolith. Until I can truly tease apart the dependencies, I have to treat it like a monolith. So that makes me really sad, but that was the first real-world problem that I came into. The next thing that I ran into is the infrastructure to spin all of this up was a serious pain, right? Because I've got to spin up app service, SQL Server, Kubernetes cluster. I've got to spin up storage. I've got to store up some Azure functions. That's a lot of things to spin up and configure. And while building this out, I've had to tear it all down, rebuild it a bunch of times. And if I have to do this through the portal all the time, it takes a lot. I mean, it takes me about an hour just to provision everything and configure everything just right. Sometimes even longer. I don't want to do that. There's got to be a better way for me to handle that as well. I have another problem as well. My microservice-based architecture in the back end is super difficult for me to join at this moment. And the reason is because they have different domains, and so all of a sudden when they try to communicate, I start getting some weird CORS issues, which is not the end of the world, because I can easily add some code that fixes that, but I kind of want to fix this without writing new code because I don't want to write new code. I'm lazy, right? So is there a solution for me to join all these backend services so it looks like it's coming in from the same URL, the same domain? I don't know. We'll see. Then we run into things like database DevOps and mobile DevOps, right? Database, I have a relational database in this project. How do I handle DevOps for it? And also with mobile, right? Mobile is very similar to like web code in terms of DevOps, but mobile has its own unique challenges. Like, how do I get this onto my testers' handsets, right, so that they can start testing it without going through the store? Or how do I even get it into the store? Or how do I run enough automated UI tests to make sure I feel good about this, except there are like, what, zillions of devices out there. How am I supposed to do all that stuff, right? So I need to figure out this mobile DevOps thing as well. And finally, we have these beautiful pipelines, right, where in theory, I can click it, and within 10, 15 minutes, everything is deployed all the way out into production. That's great, but how do I maintain quality? Am I just pushing bugs super, super fast into production? And same with security as well. We are all very aware how important security is today. Am I just pushing security holes into production all the time? Like, how do I do security and also how do I maintain quality? And finally, since this is a real-world application, I need to set up DNS and HTTPS as well. Every time I spin up new infrastructure, I need new DNS settings, right? And this is what, 2020 now? We better have HTTPS, right? So how do I set up all this stuff and get everything working? And the answer to all of this is, whoa, DevOps Nirvana, right? I can solve all of these problems through my pipeline. So what I wanted to do is kind of walk through and show you guys what I did to solve all these real-world problems. All right. So the first thing, oh, look at this. Things are succeeding. That's good. So far, so good. All right, cool. So the first thing I'm going to do is remember, I have to treat everything like a gigantic monolith, right? Which means everything starts from my build. And what I have is a build that does everything, all the pieces for me. So I happen to be using Azure DevOps Services because I work for Microsoft. And I happen to be deploying all of my infrastructure into Azure because, again, I work for Microsoft. But the thing to remember is everything that I'm showing you is just DevOps best practices. We can divorce ourselves from our tool sets, and you can still do the same type of stuff, right? So first of all, I need a build that anytime code is changed, it can kick off and build all the portions of my application. So I'm using a Windows server to build my .NET application, right? Pretty simple. First thing I do, restore my packages from NuGet, then I scan my source code using White Source Bolt. What is White Source Bolt? It's actually not a Microsoft product. It is a security product, right? It scans my repo, and it tells me if I'm using open source projects. And if I am using open source projects, it looks at the versioning that I'm using. And then it will tell me, hey, you're using an old version. These are the security holes, right? And the most recent version of White Source Bolt is super cool because they can even do things like, yes, there's a security hole in the open source library that you're using, but your code isn't touching the part that's broken. So in theory, you're safe. But you really kind of need to update your packages, right? So that's what it does. But the reason why I have that there is I wanted to show you all, how do you maintain security? The way we used to do this was at the end of the project, we would have a security audit, right? And a security audit that could take months. We don't have time to do that. So instead of trying to tack on security at the end, I need to build security into my application as I'm building it. And one of the things that we can do is add all sorts of tools in our DevOps pipeline. So for instance, for this build, we can scan our code to look for security things. What else can we add? For Azure DevOps, this is the marketplace for extensions. If I search security and hit enter, I'm going to get pages and pages and pages of security tools that you can start adding into your pipeline that does all sorts of stuff. So there are tools that can scan your code to see if you've leaked any credentials, which I happen to do way too often now that I've turned this on. There are tools out there that after you've deployed can actually automatically try to hack your application, right? There are tools right there that will look for ways to do SQL injection. So there's all these automated tools that we can start putting into our CI/CD pipelines that can really help with security. All right. The other thing that I wanted to show was this as well, right? I build my application, and then I run my unit tests. This is a half-hour talk, so I have to be really concise, right? I'm going to waste this time to talk about how important unit tests are. I am such a huge believer in unit tests. I personally don't think you can be successful in a DevOps world without unit tests. Why? Because they are our first line of defense and our best line of defense for quality. Just like with security, you do not have the luxury of time to do QA the way that we used to. Full end-to-end functional testing. Again, that can take weeks. In a big product, that can take over a month. In a massive product like, say, Windows, it might even take over a year to do full end-to-end functional testing, right? So if we don't have time to do it at the end, how do we maintain quality? You have to build your quality into your application as you're building it, not trying to tack on quality at the end. So that means as you write your code, you need to write your code in a testable manner and start testing all of your code with things like unit tests and automated UI tests that you can start putting into your pipeline. So just to show you all how important testing is, I think this is kind of a cool screen. So this is the quality dashboard of Azure DevOps Services itself. And it needs to refresh, and it takes forever to refresh because it's a lot of stuff going on. What I wanted to show you was a pull request, because this really starts highlighting the importance of unit tests. Every single developer check-in for Azure DevOps Services has to go through a pull request, right? Part of that pull request is it needs to build my application, make sure it compiles. My teammates now need to look at my code to make sure it looks good, but it also has to pass all of my L0 and L1 tests, right? All of my tests. So if we look at it, every developer check-in has to pass 27,815 unit tests. How do we at Microsoft maintain quality where every 3 weeks, like clockwork, we can push new code into production? Where every single day, multiple times a day, we're pushing bug fixes into production. How are we able to maintain quality? That's how. 27,815 unit tests, and all done underneath 3 minutes, right? Our bar is all of these tests should run under 8, And if it ever goes over 8, then we need to start looking at our tests. Maybe we need to write faster tests. Maybe some tests are stupid and we don't need them. We need to curate those as well. But that's how important quality is. Unit testing, this is how we maintain quality. All right. What else am I doing? All right, next thing I do is I package everything up so it's ready to be deployed. That's my web front end. Next, I use iOS, right? I got to build my iOS application. So this is going to use a Mac OS because you can only build iOS apps on a Mac. It's pretty typical. I wrote mine using Xamarin just because I'm a C# guy. I install my certificates. I replace tokens. What is this replace token nonsense? Actually, this is kind of funny. When I built my application, my mobile application needs to hit some back-end services, right? So my back-end services, those URLs, this is going to be different from my dev environment to my QA environment. It's going to be different than what I have in production. So how do you do that? I was like, oh, it's got to be a configuration file, right? Look for a configuration file, couldn't find it. Remember, I am not a mobile dev, right? I just play one on TV. So I pinged my buddy James Montemagno, who is our resident mobile guy. And he was just like, oh, yeah, you can't use configuration files because a configuration on a web app, a configuration file is hidden away on the server. Nobody can get to it, right? In a mobile app, your configuration file sits on your phone, which means everybody can get to it, infinitely hackable. You do not want to use configuration files. I was like, all right, cool. Don't need to yell at me, James. Why? Or how? How do you do this then? And then he told me, well, and if you all know James, he's super cheerful, right? So really, really cheerfully, he tells me, what you need to do is you need to hard code the URL into your code, and then you just build it multiple times for their different environments. And I kind of wanted to punch James' smiling little face right then and there. Because that breaks all kinds of DevOps best practices, right? We don't just you have multiple builds of the same thing. Anytime you have multiple builds, stray code potentially can flow through, right? And then I'm testing something different between my dev environment and what's going to be out in production. So what I decided was to actually do something like this. So if this is my mobile code, let me find my mobile code. Yeah, not Twitter. This is the way James wants me to do it, right? Hard code a URL. I was like, that is ridiculous. If I can just have a table that tells me for this particular build number for this particular app, in the dev environment, this is the backend URL you need to go to. And if it's in the production environment, this is the URL it needs to go to, right? It's just a simple table that I need. And then 2 APIs that says, get the new value or set the new value. That's all I need, super simple. So instead of hard coding the URL, I can just have a method that says, you know what, get me the food logs URL. And then I can call a REST API, where I can pass in my name of my application, I can pass in my build number, and then it can return me back the backend URL that I need to go to. Hooray for that. So what I need to do is during my build, I need to burn in the build number. So that is literally what I'm doing for this particular line right here. That's what I'm replacing the token. I'm taking the real build number, sticking it into the source code, and then compiling everything. All right, some other things that I'm doing, my services layer, .NET Core application, so I build my app, turn it into a Docker image. And then for my API layer, remember this is a node application. I want to run in a Kubernetes cluster. So what I ended up doing was I turned it into a Helm package. Because if I'm going to deploy into a Kubernetes cluster, Helm makes things much easier for me. So that's what I did. All right, assuming this build is successful, now I got to kick off my release pipeline, right? So here is my release pipeline. And as you can see, it's pretty complex, but it's doing a lot of freaking stuff, right? So what is it doing? The first thing that it's going to go ahead and do is it's going to deploy for me a set of tools. This is my infra tools. These are a set of internal tools that I use to help me deploy the rest of my pipeline, right? So the way that it does it is, let's go ahead and drill into it and we can see. First, I decrypt all my secrets from Key Vault so I can use my secrets. Then I provision all the infrastructure that I need for my internal tools, which is an Azure function and Azure storage. And then I deploy my Azure function. I deploy the application itself. Right. So when I provision, I'm using the Azure CLI to do that. And this is just a PowerShell script wrapping the Azure CLI call. Why didn't I use Bash? because I work for Microsoft and I Google a lot less when I'm working with PowerShell than Bash. And that is literally the only reason why. I don't care if you use PowerShell, I don't care if you use Bash, I don't care if you use any, it really doesn't matter, right? What matters is infrastructure as code is kind of cool. Right? But what do these internal tools do? Let's go ahead and take a look. Basically, it's a set of functions, and let me zoom in here so y'all can see. First thing I have is a DNS alias checker. Why do I need that? There is something that I am going to provision later that I literally cannot provision in Azure until the DNS that I want to use has propagated all the way down locally. Why? I don't know why. But this is some of those weird real-world stuff that you run into when you do stuff, right? And I'm just like, OK. So I need to be able to say, hey, this DNS name, what is the value? And is it the value that I want? And if it is, return back true. And if it's not, return back false. That's all my DNS alias checker does, because I need to know this before I can go on to my next step. Next, I have an infra-versioning stuff. What is this infra-versioning retriever and updater? To deploy my infrastructure, I have to use something like infrastructure as code. Infrastructure as code means I can use ARM templates, means I can use the Azure CLI, or I can use a third party, something like Terraform or something like that. I thought about using ARM templates, and I wanted to do something else. Because how many of y'all have worked with ARM templates? Hands are up. Cool. Super powerful, super useful, freaking awesome, right? But how many of you have used ARM templates and checked it in, and it just worked just like that? Put your hand down, because I know that doesn't happen. Oh, even better. How many of y'all have used your ARM template, deployed, get an error message, and you're like, oh, wow, that's so clear. I know exactly how to fix this now. So my point is, ARM is super powerful, super useful, but it's kind of tough to use, right? So I was like, oh, the Azure CLI would be so much easier, because I can script like that's what I do, is write code. So for this demo, I'll just use the Azure CLI. The Azure CLI is supposed to be idempotent, right? So I can run the same command over and over again, like deploy an app service. And if I run it twice, the second time it'll say, hey, the app service already exists. No op. That's what it's supposed to do. What I found out is the Azure CLI is only sort of idempotent. And by that I mean some stuff is idempotent and some stuff isn't. So I'm like, oh, do I have to have these crazy if statements? Maybe I should use Terraform, but then I have to learn something else. So then I thought, what I really want is just a delta, right? Just run the delta. Just run the stuff that has changed. And if nothing has changed, don't run my infrastructure as code script. So I thought about it, and I went, you know what? This is just like how we did stuff using, do you guys remember Code First Entity Framework? And then there was the whole migration, database migrations from one version to the next. We ran into the same problem with Code First, right? Which is, great, these SQL scripts that we create are not idempotent. And so we need to keep track of what version your database is at. So if you're on version 3 and I want to get to 5, then I can just run 4 up and 5 up, and hooray for that, I'm done. And if I'm on 5 and I want to go to 3, then I can just run 5 down, 4 down, then I'm on 3, right? So something like that. So I'm like, that's all I need to do. Once again, it's a table where I can keep track of, for this particular infrastructure, this is the version that it's at. And then when I'm running my infrastructure script, I can say, what version am I at? I'm on version 3. Oh, well, if I have a 2 up and a 3 up, then let me just go ahead and run the delta, right? I don't need to run every single up. So I created an infrastructure that does that. I have a table that holds that information, but I need an API that I can call to basically set it or to retrieve it, right? Mobile environment retriever and saver, that's the back-end stuff that I was talking about earlier. So if we want to take a look at this really quickly, I think I have data in here now. If we do, that's cool. And if I don't, we can just wait for it later. But my infrastructure versioning, as you can see, is going to be, of course, you can't see anything because it's so tiny. We've got the name of the script file, the time it was, and the version that it's at, right? That's literally all it does. All right. So those are my infrastructure tools. When I'm done deploying my infrastructure tools, then I go ahead and deploy in parallel all parts of my application, right? Why in parallel? Things take a really long time to provision in Azure. So I want to do it as quickly as possible. I'm going to parallelize it. I don't know if that's a word, but it is today. I'm going to do that as much as I possibly can, right? So if we look at, for instance, my web, Decrypt secrets from Key Vault. Why Key Vault? Because Key Vault is freaking awesome, that's why, right? Store my secrets in Key Vault. To pull it out of Key Vault, there's one simple task. I use my same secrets in a variety of my pipelines, but because I do that, Microsoft makes me change my keys all the freaking time. It feels like every other week I have to change my passwords. If I stored it inside that variable section for each individual pipeline, that means I have to find each individual pipeline and make that change there. If I use Key Vault, I make the change in one place and magically it just propagates. That's why I did it. All right. So next thing I do, I call my file, provision my web, and it says web in DB, but really all it does is provision my web. Let's take a look at that file. That file is this one right here. It's just a PowerShell script. I first pass in all the parameters that I need, and then I use the Azure CLI to first log in, and then using the Azure CLI, I provision and configure my app service. Right? That's all it does. And then at the really end, something needs to do all the bookkeeping, right? So something needs to go out and say, oh, what version is your infrastructure at? And then depending on what version your infrastructure is at, then I'll go ahead and just run the delta, right? So there needs to be a chunk of code that can do all that. It was about 100 lines of PowerShell or Bash script. I did this for Bash as well. Yes, I can Google. And it was like 100 and some lines of code. I didn't want people to copy and paste that, so I turned it into a PowerShell module. So just by copying and pasting those 5 lines of code, and by having your 1-ups and your 2-ups that wrap everything that you're doing, everything just magically works, right? Item potency, I got it now. All right, so I deploy my web app, provision, then I deploy my web app. And I do this for basically everything. But what's kind of cool, I wanted to show this for the database. Same type of stuff, right? Decrypt my secrets from Key Vault, provision everything, and then I go ahead and deploy my new schema using a DAC pack. But what's kind of cool is when I built my script for my database, again, same thing, right? This is just pass in a bunch of parameters, use the Azure CLI to log in, and then the first time I defined my infrastructure, I created my SQL server, and I set up all the connection strings, and I set up a whole bunch of configuration stuff, and then after I ran this, it dawned on me, hey, if I'm going through this, because I'm only running the deltas, that means somebody deleted my database. And because it's in Azure, automatic backups are taken, which means when I provision this from the ground up like this, why don't I just go to that location? I know where my backups are. Why don't I just restore from backups? Because if I do that, then I have disaster recovery built into my pipeline now. So for my 2-up, that's exactly what I did. Is now I go to the storage that's holding my backups, and I restore everything from backup. So we're doing disaster recovery as well in my pipeline. All right. Next things that we do, we deploy my API services into a Kubernetes cluster. I'm actually using an ARM template this time because I actually had one that worked. And I deploy using Helm. And what else do we do? We deploy our mobile app using App Center. App Center is a series of tools for mobile-type applications, which makes it super easy to build and deploy. And I also set up DNS, right? What is DNS? DNS is held in Cloudflare. Cloudflare has a full set of REST APIs that lets me do every type of configuration. So guess what? Within my pipeline, I have a script that calls those REST APIs that sets all of my DNS stuff for me. Now, the next thing that I need to do is deploy into Azure Front Door, right? Azure Front Door is that thing that won't let me deploy until DNS is propagated. So what I've done is if we go ahead and jump to my real-life deployment, I've created a gate. This is a post-deployment gate. So you can have manual approvers. You can also have automated approvers, right? So this is an automated gate that's checking my DNS. So it's pinging that function that I wrote earlier. Hey, did DNS propagate? And if it didn't, it waits 5 minutes and asks again. 24 hours, it will time out. But this passed really quickly because DNS flows pretty quickly. So hooray for that. It goes to the next step where I then go ahead and deploy my front door instance. And then after I do that, I run a series of automated UI tests for everything, for the web and also for the mobile. And now, in theory, if everything works, then my application should be up and going, right? So if I go into my resource center, let's refresh this really quickly. Dun, dun, dun. Here is my Mercury Health Resource Group. Very cool. I jump in here. We see a bunch of resources that's been provisioned, including things like a Kubernetes cluster, app service, database. We refresh this, and bam, there's the application deployed. Now remember, I said we did disaster recovery, right? Let's go ahead and check and see if we did. So if I click on this exercise link, it should come back with a list of the exercises that I've done. And if it's successful, we'll see that list. And if it's not, we'll see an empty list. So yeah, real life disaster recovery. And I know I'm out of time, but I want one more thing. Check this out, peeps. That URL, this is not an Azure URL. That's using my DNS name because I set it up in my pipeline. And that lock is in the lock position because I also set up HTTPS. This is a real world pipeline. So my point, again, is not how great Azure is or how great Azure DevOps is. I want you all to use DevOps best practices. So go out there, let's start building pipelines and automating the world. Thank you all.
All right. Thank you, Abel.
I cannot
Great
believe
job.
I got through all that in 30 minutes.
There you go.
All right. I want to throw this out there too. I know this was super fast. If you guys want more details on what I'm doing, all the information about this presentation, including all of my source code, including all of my repos, including all of my, everything is in these links, right? Also, if you have questions, feel free to ping me on Twitter.
My real challenge going end to end and putting DevOps practices into place as discussed here is how much time should this take? We always have a problem in projecting the time that we'll need to spend, especially when it comes to some of the new technologies that we're wanting to introduce. So it sounds fantastic and everybody's on board, but it's about how long did it take you to get from point A to point Z in a realistic manner.
Can you answer this?
Yeah, absolutely.
All right, cool. So if you're just starting out, should you build a pipeline like this? Absolutely not. Why would you need to put DNS in your pipeline, right? However, the thing with DevOps is it's a continuous improvement, right? You're always supposed to look from one iteration to the next and be like, what can I do better? So I don't expect you to build a pipeline like this day one, because yes, it took me a while to build that pipeline, and I do this all the time, right? Build a much simpler pipeline, but for your next sprint, look at it and be like, oh, what hurt when I used my pipeline, which is exactly what I did, except I just did it all at once, right? What hurt for me was infrastructure. So I knew I had to do infrastructure as code. Next, what hurt for me was setting up DNS all the time. That was a pain to log into Cloudflare and type it in through the browser. I was like, can I automate that? And then the next, I was like, the database backup thing, I was just like, oh, can I add that? Is it even possible? I don't know. But then I tried it and it worked, and I was like, oh, I got to put it in my demo. This is going to be awesome, right? But my point is, build out a simple pipeline, find one thing that hurts, fix that for the next iteration, and then iterate over that over and over.
So me and one of my colleagues actually went to a DevOps boot camp over the weekend. It was called DevOps Boot Camp, actually. I believe it was a very complicated name. And Yep. It was a global DevOps boot camp. So there's another one coming up this year, but we learned a ton of just emergency scenarios really quickly of how to do things. It was we learned how to fix these pipelines, how to create new pipelines. And when we came on to Monday, me and him had a couple ideas, and we just knocked them out by the end of the first sprint. And I think now we are half a year post then, maybe a half a year's post then, and he's pretty much run with it and pretty much automated a ton of things. Plug for Sonali's presentation tomorrow, but you'll hear a lot about this in Project Smooth's Streamline project of how we actually tackled a lot of these things.
All right, I'll go ahead and say like some of the.
But you have to say it in the form of a question.
What is Sonali's presentation? I guess one of the challenges that I've run through over the years and stuff like that with pipelines is like I've got a client that takes 45 minutes because of infrastructure, right? Like Dev Test Labs, for example, once it provisions out artifacts, and it was a brilliant idea, I love it, but sometimes it's really slow. Then the problem never happens at the beginning of the pipeline. It's always like, your 8th step in or something like that, and that's when it fails. And sometimes like you need, like with DNS, for example, I've had to deal with that before, where you have to wait for provision because app services or whatever it was won't check it, and yeah, I'm well versed in that situation. Test like that failure point and stuff like that. You need those previous values in there. So it almost be easier if there's like you could sandbox it to make sure it could work somehow without having to take 45 minutes. Like ARM template validation just validates, but it doesn't really tell you if it's going to work. If that makes sense.
So
it doesn't make.
it sounds like you want like a quick way to validate. Oh, this pipeline most likely will work fine. Right. Go ahead and do it. Or immediate red flags. These things are not set up correctly. It's gonna crater.
Yeah. It's a big ask.
Can you do that? I think absolutely I can. I think I can make this pipeline do exactly what you said, right? Because I know where the pain points are. First, I need to make sure that the Kubernetes cluster that I'm provisioning can actually be provisioned in the data center that I picked, right? Because I'm doing everything in Azure. If I'm doing it some other infrastructure, I'd have different problems, right? Cloudflare, sometimes their REST API just goes down for no apparent reason. Well, probably because they're free and I'm not paying any money for them, right? So things like that. So there are some common, exactly, right? So there are some common places that I know will break. I can build tests to really verify that quickly.
But when you're creating it the first time, for example.
Use the mic for recording.
Sorry.
That's okay.
I won't touch it though. I'm saying like especially your initial, like if you're building a new pipeline or something like that, sometimes the problems that like begin with some clients I'll run into is that like, hey, it takes, as you're building it, that first time to figure out even where your first pain points are. Sometimes that build takes forever to do, and then it's like 45, if you ever get one that runs, which is ridiculous, but hey, I can't control Dev Test Labs, so.
I cannot control Dev Test Labs.
Damn it.
Are you using the validate only mode for
No, that
ARM
doesn't
templates?
matter once it provisions.
No, once it
Yeah,
provisions.
it validates, it's fine, but then there's
Yeah.
something wrong with provisioning.
Right, right. Yeah,
Get on
there's
it, Dave.
Another level. Yep, yep.
But that you make a very good point, and I'll run back to the PG and see if there's anything we can do to do like pipeline validations. Yeah.
So do you mean just validating the infrastructure itself or what they all do together? Because I've heard recently with some of our customers, some of them were saying, oh, well, if we're using Terraform, for example, we want to validate that it's working correctly. Well, that doesn't really make any sense because then you're testing Terraform's code. What you can do is conformance testing. There are tools out there to make sure that if you have a group of servers, there's between 2 and 8 and no less and no more. And then you can have your automated smoke test before you go into your functional test. So if I've stood up all of my various infrastructure and then I run a quick set, and the infrastructure is going to take the time it takes. There's nothing you can really do about that.
Right.
And then you're going to run a set of really simple smoke tests to make sure that they're all actually connected and working. And you can do that. And then you go on to your, it's just a matter of structuring the validation at the right time.
Okay, I do need to move us on for time. So yes, if you want to.
Do you guys want to come over here? Yeah.
Yeah, I'll move us on for time, but if you do want to continue the discussions, remember we do have the room across the hall for gathering around the tables and continuing the discussion. So next question, what successes have you had in this area that you want to share?
For me, one of the simplest things or hardest things I guess I had to do was to integrate Azure DevOps and GitHub, and also add in the ability to do release gates right along in the middle. And so for me, it was more of educating our compliance team and our service desk team on what exactly is happening between these two. So Chris, my team member, was able to help me figure it out that way to get that to work right.
Cool. I love what you just said.
Yeah. So we're building. We have an application built on top of a first service fabric and now Kubernetes cluster. If I was talking about the challenge, I would tell you the horror story about version 1 and the practices that weren't being followed. But the good thing that came from that was we're thinking about version 2 now, and because of all the horror stories and pain and all the blood that was shed from version 1, everyone was like, yeah, let's do best practices now for version 2.
practices exist for a reason, right? And it's not when things are going well. When things are going good, who cares, right? But best practices exist to save our butts when things go bad.
I know I picked on time being an issue. However, I will say that one of the successes out of trying to utilize best practices is it becomes a lot easier how to display to others how to do bite-sized chunks. Because if it can't fit within the pipeline, it's probably not time for that piece in the pipeline. And that was one of the things that got exhibited earlier when we were trying to do Kubernetes deployments is, hey, we don't have the infrastructure to do this. That infrastructure is going to take time.
All right, so in this area of real-world DevOps, what are your pain points? Abel said, what hurts the most? Work on that first. So what do you want to tell Microsoft and Terraform and others? What do you want to see in 2 to 5 years?
So the biggest nightmare I have with this whole pipeline development and progression with adoption of DevOps is how you build a robust administration and monitoring solution. So in the event of failure, when you have multiple departments in IT involved for TNS automation or service account automation, code deployment, you need to build a model for what is that support structure like? What is that cross-functional support structure that can respond in timely fashion based on the monitoring solution? So that is something that we in Coyote are trying to explore and get better with. But that's any seamless way of solutioning that problem would be something we'd like to see. Yeah. All right. I guess I'll talk to you in a year and see.
You said 2 to 5.
Well, we'll do it iteratively, right? So we talk every 6 months.
We can talk much sooner than that, too.
Maybe just too specific for me. I'm interested in, maybe it doesn't take that long. So in your examples, there were scripts, PowerShell modules mentioned from the pipeline stages, but there was basically assumptions that using these variables and these hard-coded paths, I will get to actual module, and you will only learn whether this is a correct step once you execute on top of particular build machine, and that build machine will have to be populated with those scripts. Right when you were invoking PowerShell modules from the pipeline.
Yes, but I can start from any build machine and it will work. It needs to have PowerShell. It needs to have the right version of PowerShell. But if it does, I'm pulling and installing the PowerShell module from, PowerShell Gallery, right? So I think that's what it's called. Yeah. So it's literally downloading my module in real time.
Yes, but is it done by that particular stage, or by the stage itself?
Yep. The 5 lines of code that I asked you to copy and paste, that literally will say, that's literally telling it, go to the PowerShell gallery, download this module, install it, and then run it and pass in these parameters.
Okay, so this is a cool thing from the future. Is it possible to have a PowerShell step that will understand which functions you have available in that module, and it will give you, UI to construct that, so that you don't need to build command line yourself, because it's still error prone, if I understand it correctly.
Yeah. So to answer that, maybe in 2 to 5 years, I don't know. But I agree with you. It'd be really cool if we had some visual tools that could help us do a lot of that.
And actually, I also wanted to ask a question about, so this pipeline was super complicated and big, and if you look at this YAML, it's probably multiple pages. So now, and there is infrastructure as code in terms of the steps are relying on some automation that's already checked in somewhere, and you can download it and call it. But now the pipeline itself, it's a part of what kind of infrastructure, what kind of repository holds it. How, let's say tomorrow I want to build different mobile app, but I still want to go through all of the steps that you implemented there. Yeah. How can we successfully benefit from huge pipelines that are inheriting from each other, or maybe sharing some, like polymorphic pipelines?
So can you do that today? You can't, right? Because it's just one YAML file or multiple YAML files per repository. But I agree, it sure would be kind of cool if you can inherit from a particular pipeline and then just make whatever changes you need to, right? The nice thing about what you can do right now is a lot of times if I'm using the same type of pipelines, the only thing I need to change is the parameters I'm passing in, right? But like you're saying, if I want to make some changes, I'm copying and pasting, right? So it could be better.
You could still use essential. We're doing this now, and I think, I can't remember whose last talk had that, but she's right over there, I think. We're using templates. And sorry, I forgot your name, I apologize. Mandy, okay. So Mandy gave a talk about this about using templates, for example, and where I think it's almost a similar solution to what you're talking about, where like you could technically pull from a repo, because you have multi-repository support now, and that would be your template or your base pipeline, and then you can just override values at that point. You can correct me if I'm wrong.
Super
But
cool.
I think it was the in-house solution that they made. It's not something that's supported in DevOps. Inheritance of templates?
We're just using hosted pipelines
Yeah.
and the built-in YAML templates and our PowerShell module with all. Sorry.
For those on the recording.
So we have a bunch of YAML templates. That's just part of Azure DevOps. We don't have any on-premise build or pipeline servers. They're all hosted. And so we also have a PowerShell module with all our custom logic. There's a bunch of integration testing around that. We publish that as an artifact into Azure DevOps. And then we have templates that when we want to deploy a resource into Azure, I'm simplifying all this, obviously, it will pull that PowerShell module down, the most recent version, make it available on that hosted pipeline server, and then the YAML templates call our custom PowerShell commandlets that way. And so that's how we standardize everything, basically, to kind of do what you're talking about.
Yep.
Okay. We're right at time. Any final